Good morning, everyone. We are going to talk about another way to factor. It's what we call the difference of squares. Okay, so before we do that, we're going to FOIL a couple things here. So go ahead, pause the video and FOIL this for me like we've done in the past. So if you use the box method, that's fine. I'm just going to use regular FOIL today. So x times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. And if I were to simplify that, that would be x squared plus 8x plus 16, because I have to combine my like terms. Okay? Now if we go to the next one here, very similar problem. So go ahead, pause it, see if you can FOIL it without my help. X times x gives me x squared. X times 4 is plus 4x. Negative 4 times x is minus 4x. And negative 4 times 4 is minus 16. Now what happens here is when we combine our like terms, 4x minus 4x cancels to be 0, so I'm just left with x squared minus 16. Okay, so you can kind of see the difference between these. Okay, and the only thing we have an x and a 4, x and a 4, x and a 4, x and a 4. The only difference is these have both pluses, and this has one minus and one plus. So we have the exact same terms inside, just different signs. Okay, and when that happens, this creates what we call a difference of squares, okay? So we get x squared minus 16. So x squared is a perfect squared because x times x is x squared. And 16 is a perfect square because 4 times 4 is 16. And if we look back at all of our perfect squares, we know that 4 is a perfect square because 2 times 2, 9 is 3 times 3, 16 is 4 times 4, 5 is times 5 is 25. 6 times 6 is 36, we have 49 for 7, and then 8 would be 64, and then we have 81, and so on and so forth, right? We have all these perfect squares, okay? So if you don't have these memorized quite yet, and we should have them memorized up to 100, so 100, probably 121, and even 144. These should be recognizable to you, sorry guys, these should be recognizable to you as perfect squares, okay? So if you don't have those memorized, I would work on those while you're having some class time off, okay? So the shorthand for difference of squares, if we have two squares being subtracted, remember difference means subtraction, right? Not adding. We can write the first term and the second term in both parentheses and one minus and one plus. So let's go ahead and look at this. And we should always check for the greatest common factor first. So if I'm looking at my greatest common factor, there isn't one because this has a leading coefficient of 1. There's nothing in common between 1 and 81 besides 1, so that's not helpful. So I'm going to write my two sets of parentheses. And we know from before to get x squared, that is x times x. And 81 is a perfect square. So difference of squares will only have two terms, and the first term will be a perfect square, so x squared or y squared or 4y squared. And the second term will also be a perfect square. So 81 is a perfect square. So I know 81 is 9 times 9. Now whenever we have difference of squares, we'll have 1 plus and 1 minus. It doesn't matter which one comes first, so the minus could come first. Okay? So my final answer is going to be x plus 9 times x minus 9. So the terms, the parentheses will look almost identical, except one will be plus and one will be minus. And we can FOIL that to check ourselves. So x times x is x squared. X times negative 9 is negative 9x plus 9x minus 81. So my middle terms cross off to get x squared minus 81 back. Okay? Alright, let's try another one. Now this one, again, we want to see if there's a greatest common factor. There's nothing in common with 9p squared and 16q squared. But I'm going to check to see, since I have two terms and I'm subtracting, to make sure they're perfect squares. 9 is a perfect square. P squared is a perfect square because p times p is p squared. 16 is a perfect square because 4 times 4 gives me 16. And q squared is a perfect square because q times q is q squared. So what I'm going to do is I'm going to sit here and I'm going to look at each one. And I'm going to say, okay, and sometimes it's helpful to write this right above it. Okay, so the perfect square for 9 would be 3. And the perfect square for p squared would be p. And the perfect square for 16 would be 4. Or the square root, I should really be saying. And the square root of q squared we know is q, right? So 3p times 3p will give me 9p squared. And 4q times 4q will give me 16q squared. So I'm going to have a 3p and a 4q in this parenthesis. and I'm going to have a 3p and a 4q in this parenthesis. And I'm going to have 1 plus and 1 minus. So my final answer looks like 3p plus 4q times 3p minus 4q. Now again, I could switch these up if I wanted to. I could write the minus in this one and the plus in this one. It doesn't matter which order they go in, we'll get the same answer. And I should check my work. 3p times 3p is 9p squared. 3p times 4q is plus 12pq. Oops, that's a G. Negative 4q times 3p would be negative 12pq. Remember, we write the variables in order just so we can tell when things match up. And then 4q, negative 4q times 4q would be minus 16q squared. And again, my middle terms cancel, which I wanted to happen, so I'm left with 9p squared minus 16q squared, which conveniently is my original answer. Okay, so my final answer here would be this set of parentheses. Okay, this is just checking my work. All right. Go ahead, why don't you try this final one on your own and see what you get. Okay. So, I didn't add this, but 1 is also a perfect square. Okay, because 1 times 1 is 1. Okay. So, when I'm looking at this, 1 times 1 gives me 1. So 1 is a perfect square. 25 is a perfect square because 5 times 5 is 25. And y squared is a perfect square because y times y is y squared. So again, I just kind of wrote these up top, so I don't really have to think about it while I'm writing my parentheses. Again, my final answer will be 2 sets of parentheses, so I'm going to have a 1 and a 5y, a 1 and a 5y. Now it's important because the 25y squared was the second term that it goes in the second spot of the parentheses. I can't flip the 5y and the 1 around. So then I'm going to do 1 plus and 1 minus. Again, it doesn't matter which one you choose to go first. And again, I could check myself. 1 times 1 is 1. 1 times 5y is minus 5y. 1 times 5y is a positive 5y. And 5y times negative 5y would be negative 25y squared. And again, my middle terms cancel out to leave me with 1 minus 25y squared. Now, if for some reason you accidentally put the 5y in front, then you would have 25y squared minus 1, which we know is not the exact same thing. So make sure if this part is second, it goes second in each parenthesis. Okay? Hopefully that is helpful to you. Go ahead and try the homework, which is posted here. And if you have any questions,